Hey there, this is Tony Verbsky again. I'm going to finish off our third lecture of 3 over section 10.3. These are formulas that you traditionally do not memorize, but you need to know they exist. They're very helpful to know in calculus, and they're both good forms, but depending on what you're doing with the equation, you want one form or the other. So cosmetically it looks great, but maybe not with respect to calculus, it's not great. So here we go. So we're going to recall, but we're not going to write recall. We're going to just go cosine alpha plus beta. And right below it, we're going to write cosine of alpha minus beta. And then we go cos, sin. And you go cos, sin. Once again, cos is cosine, sin is sine. Alpha, beta, alpha, beta, alpha. Plus is minus is plus. And what do you say? We add them. So cosine alpha plus beta plus cosine alpha minus beta equals just 2 cosine alpha cosine beta, because these are opposite in sign. So right here is, this comes up a lot in math. So we get cosine alpha cosine beta equals cosine alpha plus beta plus cosine alpha minus beta times 1/2. And that's one of the 4 identities that I'm going to give you here. So by the same process, using cosine of alpha plus or minus beta and sine of alpha plus or minus beta, by adding and subtracting them, we get these 4 things. Here's number 1. I'll tell you, if I'm in a calculus situation doing this thing called the antiderivative, I can't do it in this format right here, but I can easily do it in this format on the left. Anyway, moving on. We get sine alpha sine beta to be 1/2 cosine alpha minus beta minus cosine alpha plus beta. We get sine alpha cosine beta to be 1/2 sine alpha plus beta plus sine alpha. Well, let's switch. We get a little careless here. A alpha minus beta. And I might as well fix this up here. Alpha plus beta. Alpha plus beta. And then finally, cosine alpha sine beta equals 1/2 sine alpha plus beta minus sine alpha minus beta. So, for example, if you get cosine of 7x sine of 4x, that's really 1/2 sine, add the two, 11x minus sine, subtract the two, 3x. So once again, in calculus, I cannot do this problem, this one right here. Don't know how. Ooh, there's got to be a little symbolic dx there. But if I know this, I can just look at it and answer it, because If I write this down and know what this is, I know the answer, this calculus answer, it's minus 1/22 cosine 11x over 11 plus 1/6 cos 3x over 3 more, plus some arbitrary constant c. So this doesn't work well in calculus, but if I know the formula, I can get the answer in calculus. If I don't know the formula, well, it's just not happening. And that's what we use it for. I do like this form for algebra, maybe finding x-intercepts. Anyway, you can see I use the formula sine alpha plus or minus beta and cosine alpha plus or minus beta, manipulate them around and created 4 really useful formulas. Now, it's a little trickier, but there are 4 more coming. Sine alpha plus sine beta. In calculus, we're fine with that. But if you'd like it to make it look prettier and perhaps find x-intercepts, you got to learn that it's alpha plus beta over 2 cosine alpha minus beta over 2. And the proof is actually fairly easy. All you do is take the last equations I gave you, do a little substitution, and bam, you pick up these equations. And then sine alpha minus sine beta is 2 cosine alpha plus beta over 2 sine alpha minus beta over 2. And then cosine alpha plus cosine beta is 2 cosine alpha plus beta over 2 cosine alpha minus beta over 2. And finally, cosine alpha minus cosine beta is 2, with a negative, sine alpha plus beta over 2 sine alpha minus beta over 2. So, not that I despise cosine of 7x minus cosine of 4x, but it can be rewritten as negative 2 sine of 11x over 2 sine of 3x over 2. This is a prettier form, way easier to do algebra, like finding x-intercepts, because basically it's in factored form, where this over here, well, algebraically, that's a nightmare. So there's reasons to be able to go back and forth. So they're called sum to product and product to sum formulas. They're pretty good formulas. In my math life, I use them, but only once or twice a year, like in real life, not in my teaching life, of course. But they do come up. It's nice to know they exist. That's why most people actually, get a formula sheet. And I'm to the point where I can, attach a formula sheet to our Google Doc and just know that these are generally not memorized and just need to know how to use them. Now, my math lab, I don't know what they have in store for us. I got to work your problems too, remember. So we'll check it out, and hopefully it's not too crazy. But usually these problems are fairly easy, just because it's mostly can you transform it from one form to the other. That's usually what it's all about. Anyway, that's the last of lecture 3. See you next time. Bye.